A colony of bees is being studied. The number of bees in the colony at the start of the study was 30,000. 3 years after the start of the study, the number of bees in the colony is 34,000. A model predicts that the number of bees in the colony will increase by P percentage each year, so that the number of bees in the colony at the end of each year of study forms a geometric sequence. Assuming the model, find the value of P, giving your answer to 2 decimal places. So first of all, this is a geometric sequence. And here P percentage represents the percentage increase, and it is not the common ratio that we need to find out here. In order to get percentage increase, we have to get the common ratio. And that is one thing about this question. And another thing is, this is a geometric sequence. The nth term formula, we know nth term formula is a into r to the power of n minus 1. So it's given that the number of bees in the colony at the start of the study. So let n be 1 at the start of the study, and it was 30,000. It is at the start of the study. Now, at the end of 1 year, let's say n is equals to 2. At the end of 1 year, let's say n is equals to 2. At the end of 2 years, n will be 3. And at the end of 3 years, n will be 4. And it's given that at the end of 3 years, there are 34,000 bees in the colony. So the common mistake is that since you have seen that 3 years after the start of the study, you may write the answer for n as you may write n as 3, but that is not the correct way. So it's given that at the start of the study, that means it's not at the end of first year, it's beginning of the first year. Beginning of the first year, it was 30,000. At the end of first year, let's say the n is equals to 2, we don't know the value. And at the end of 2 years, let's say n is equals to 3. And at the end of 3 years, n will be 4. So fourth term, a4 here, is equals to a into r to the power of 4 minus 1, which is 3. Fourth term, it's given as 34,000 bees are there. And initially there was 30,000 r cube. So r cube will be 34,000 divided by 30,000, which is 17 over 15. So from r cube to get r, it will be cube root of 17 over 15. So when you do cube root of 17 over 15, that will be 1.0426. 1.0426. So now this is the common ratio, and this act as the multiplier here. So 1.0426 means what? This is 100 percentage plus an additional 4.26 percentage. That is what here 1.0426 actually represents. So 100 percentage plus 4.26 percentage is 104.26 percentage, which is basically 104.26 when we represent it as a fraction. So this will be 104.26 divided by 100, which will give you 1.0426. That is the common ratio. So here there is a 4.26 percentage increase each year. There is a 4.26 percentage increase each year. So this is what the question is all about, percentage increase. So percentage increase in this case will be 4.26. So as I said, the question was to find percentage increase. In order to find out percentage increase, we have to find out what common ratio is. Common ratio was 1.0426. That is basically 100 plus 4.26 percentage. That is 104.26 percentage. Percentage, how do we convert it into decimal? Divide by 100. 104.26 divided by 100, you will get 1.0426. That is the common ratio. So this percentage increase, after every year, there will be a percentage in 4.26 percentage increase. So that will be the value for P. Now moving on to the next part, that is, according to the model, at the end of n years of study, the number of bees in the colony exceeds 75,000. Find, showing all steps in your working, the smallest integer value for n. So let's just do the B part here. So I'll just use a different color for that. Okay. So B part, uh, we can see here at the 3 years after the start of the study, it was represented as AR cube. 3 years after the start of the study is represented as AR cube. So n years after the start of the study means AR to the power of n. I repeat, 3 years after the start of the study was represented by what? AR cube. So here it is n years after the start of the study. This will be AR to the power of n. It's given as 75,000. So A we already know, it is 30,000. So 30,000 into R to the power of n is 75,000. Therefore, R to the power of n will be 75,000 divided by 30,000, which is 5 by 2, which is 2.5. So R to the power of n is 2.5, and we know the value for R, that is 1.0426 to the power of n is 2.5. This is an exponential. So in order to find the value for n, let's use logarithm. So log of 1.0426 to the power of n is log 2.5. So log x to the power of n, we know the rule, log x to the power of n is n log x. So this will become n log 1.0426 is equals to log 2.5. So n will be log 2.5 divided by log 1.0426. Let's just put that in calculator. Log 2.5 divided by log 1.0426, which will give us 21.96. So approximately, when we round it, we'll get n as 22. So according to the model, at the end of 22 years of study, the number of bees in the colony will exceed 75,000. So I hope you have understood this. If you have any doubt, feel free to write it in the comment box. Thank you for watching.